Hello, can you hear me? All right, welcome back to web development. So let's see. So we are on the second half of the course, right? We're more or less halfway through the semester, and we have been mostly focusing our attention in building a user interface with a React.js web application. And we definitely can interact with users. We can render stuff on the screen. We can provide forms for users to enter data. We can maintain some kind of state, right? We can remember, uh, the state of variables as they change over time, where users might add new content, remove content. We can navigate between multiple screens, and they can interact with one another, passing data across, encoding it in the URL. So there's quite a bit of things that we can do, from the user point of view, right? From the user interface point of view. But we do have some limitations, right? We can't, for instance, make our changes permanent, right? If we add content, remove content, or update something, if we refresh the screen, the browser, right, everything's gone, right? It resets to its original state. So that's one limitation. We don't have access to a database, for instance, right, where we can make some permanent storage solutions. We don't have unfettered access to the internet, right? We can't just connect. I mean, we can, depending on some services that do permit, but in general, it's limited options, right? Or what we can do from a user interface. So today we're going to introduce servers, right? We're going to introduce uh, being able to build something that runs outside of the browser, right? So that we can escape the confinements of the browser, right? And that's where the server comes in. A server is going to execute outside of the browser. It's going to execute just on a regular command line, and so it's going to have unfettered access to the file system, right? It'll be able to connect to a database. It'll be able to connect anywhere on the internet, and so we're going to move all the things that all the operations that we can't do on a browser, right? We're going to move them over to the server. Right? And then we're going to have to integrate these two pieces, right? The browser still fulfilling its role as a user interface, interacting with the user, letting them, type at the keyboard, move their mouse, right, and enter data, navigate. But then, anything that has to do with making changes to the state of the application, right, that needs to happen on the server. The server will maintain the state of the application, right? And make permanent changes stored in the database, right? Also allow us to connect to the network, right? To the internet anywhere we want, right? Access to the file system, right? But then it's going to be the second half of a whole thing, right? We've been working on one of the half of our application, and now we're going to integrate with a server, right, through an HTTP network connection between the two, right? And they're going to be able to complement each other, right? All the things that we could not do in the browser, now we're going to do on the server. And the things that we can't do on the server, right, we can do on the browser, right? And everything through an API, RESTful API connection, right, running on top of HTTP. Okay, so that's the focus for the next couple of weeks, right? We're going to be building a Node.js HTTP server, right, and integrating it with the front end, right, through an Axios HTTP API. Okay. Also, the quiz 6 should be now available. Right? It'll be available for the whole week. We're going to introduce the fifth assignment. Right, this is the next to last assignment. Right, introduces servers. After this, we're going to introduce the databases, how to integrate with databases. We'll use a MongoDB non-relational database as a permanent storage solution. Right? In all this, right, you should also be working with on the project, right? You should have a team. Should establish a team of folks that you want to work with. And again, we've covered several options, right? add the quizzes support for the Canvas application that we've been working throughout the semester, right? Or add the Piazza implementation, right? A clone version of Piazza, or the what I call the social network application, which is more or less it's a open-ended application, basically whatever you want to implement, but it needs to have some certain features, right? So right, if you don't want to work on the extensions of the Canvas application, you want to do something more on your own, right? You can go the social network route, right? And I think the requirements that I've given in that project description, right, is broad enough, it's general enough that you should be able to fit whatever it is that you want to build, right? At least I hope 80%, 90% of whatever you can come up with, right, should be covered under that option. It doesn't have to be explicitly a social network website, right? But there has to be some interaction between users, right? Between where they can send message to each other or follow each other, or some kind of relationship between users. Okay. Anyway, let's get started. Any questions? All right, let's get started. All right, so let's talk about HTTP servers, right, in the context of the web application, right, that we're trying to build, right, within the context of building, a web application where you have the architecture of a front end, right, implemented with React, right, and then on the server side, right, we're going to have a Node.js HTTP server. So this is the architecture of what it is that we're building, right, and we have been, focusing most of our efforts on the first half, right, of this web application. But it's going to consist of two large pieces, right, that we refer to as a client server architecture, right? We have on the right here on the left side the client side, right, and we have on the right hand side here we have the server side, right? And what we've been focusing most of our attention on the first half, where we're building the a user interface, right, that can interact with users, where users can click and drag and move their mouse, right, and see a visual feedback of their actions, right. The first couple of technologies that we covered was HTML and CSS, where we can lay out content, right, and then style it to make it look pretty and more appealing and more professional, right? So we discussed these two languages, these two um, declarative languages, right? They're not functional languages. They're not object oriented. They just declare that certain things should be rendered as paragraphs, as headings, as lists or tables, and that certain things should be justified to the left, to the right, right? And certain border colors and foreground colors, background colors. So these two languages are declarative language. They declare certain aspects of how things should be displayed on the screen. And so most of the first effort that we learned about was how to create static content using HTML and CSS, all within a React.js application, right? All this embedded inside of TypeScript, right? But that TypeScript was mostly being used for creating these functions, right? That were wrapping some static HTML, some static CSS, right? That were, their return value was these code snippets, these HTML snippets that were combined, right? Collated between multiple functions that, combine all this HTML from various functions into one big, concatenated HTML that was then injected into the DOM, right? So that was the mostly the first effort, right, in the first 2 or 3 assignments, right? We then started looking at a TypeScript for implementing things that were a little more advanced, right? Where we would use TypeScript also to maintain a state, right? Of as users interacted with the application, right? The data structures modified over time, right? We would modify a property, or we would add a new object at the end of an array, right? And then those changes cause the re-rendering of the front end, to give feedback to the user that those changes uh, were taking effect, right? Now, and uh, those are very important aspects of a web application, but you have some limitations, right? That we cannot overcome, just with a React application, right? So that's where the server comes in. That we're going to be able to have full access to the operating system that we're running on, because this is going to be just a command line, right? With a whole bunch of libraries, right, that are going to be able to integrate with the database, and also create a server that can integrate with the user interface, right? And so it's going to be able to we're going to be able to implement a lot of the things that we cannot implement on the browser, right? For instance, maintaining sessions, right? Right now, our implementation can be used only by one user, right? Whenever we go to to the URL of a web application, for the ones that we've been building so far, right? It's intended to be used by a single user, right? If some other user goes to the same URL, right, they are served a completely different instance of that same application, right? They're not designed to be used by more than one user, right? Or they're not designed to remember a user, right? If it's the same user coming repeatedly, right? So they can distinguish requests coming from one user or the next, right? So all those aspects we're going to be able to overcome using the server. Okay. First, we're going to discuss Express and how to implement RESTful APIs. Right. So this is going to be the part where we're going to be gluing, or we're going to be connecting, these two pieces, right? The front end, right, and the back end, right, the server, right, or well, actually not the back end, the middle tier. Yeah, oftentimes this server is referred to as the middle tier, since it's kind of sits in between, right, two large parts, architectural parts of an application, right, the user interface and the back end, right, which oftentimes is some kind of service or database or some other resources, right, that are enterprise resources of the company or institution, right? And the server kind of sits in between, oftentimes referred to as a middle tier, right? This is multiple tiered application, where the first tier is the user interface. You have the middle tier, you have the server, right? And then you have other tiers down further, deeper into the infrastructure, right? So anyway, so this is going to be the endpoint, right? That is going to allow us to integrate the client side with the server, right? It's going to be able to receive HTTP requests, right, from the client. The client is going to be sending HTTP requests out to the server, and the server is going to use we're going to be using a library called Express, right? That's going to allow us to implement endpoints that can receive these requests, right, coming from the browser, right, from the client, right, and then computing some response, right, sending it back to the client. We're then going to discuss sessions, so that we can support, folks being able to log in, right, identify themselves, who are they, right, so that we can maintain a conversation with the same person, the same identity. As the person identifies themselves, we'll be able to reinstantiate, state information that is specific to that person, right, and have a conversation, right? If somebody is manipulating their shopping cart, we should be able to distinguish, right, one shopping cart from one user from another shopping cart from another user, right, and be able to simultaneously maintain conversations with multiple users, right? So servers are going to be able to do that, right? There might be dozens of these clients, right, or hundreds. Could be thousands of these client applications running on thousands of browsers, all talking to the same server, right? And the server needs to be able to distinguish, right, what conversation comes from where, right, so that you can maintain them separate from each other, right? And finally, later in the next couple of weeks, we're going to introduce integration with a database, right? We're going to be using a library called Mongoose, right, to be able to log in and connect to a Node.js, MongoDB non-relational database, right? And that will serve as the permanent storage solution, right, in our web application. Okay. Right. So yeah, so we've said that our overall architecture for the application that we're building is the client server application, right? And typically the way these two pieces talk to one another is what we refer to as a request response, right? The client makes a request, sends it over to the server. The server does some computation, does some work, right? And then the result of that computation is then sent back as a response to the client. Now, in our case, right, this architecture is very generic, very general. It can be implemented in any number of infrastructures, different technologies, right? And now a very specific implementation of this architecture is what we're doing, right? Where in our case, the client is a JavaScript code that is running on a browser, right? And that is what we refer to as a client. Now, this client could have been something different. It could have been a mobile phone, right? Or it could have been a game console, right? Or it could have been just another application that knows how to, send network requests. Okay. In our case, right, our client is the React application that we've been building so far, right? That is running on a browser, right? And again, it could have been just a, you know, a console application running on a desktop, right? So as long as your client can, generate requests, right, and then consume responses, then it's a client. In our case, right, it's implemented as a React application running in a browser. Now, for our server, there's also many options of how to build a server, right? And we could have used Python, right? We could have used a C# server, right? It could have been a Tomcat server. Oracle has lots of implementations. Microsoft has lots of each vendor, each large player in this space has their own server, right? We're going to be using specifically Node.js, right? Node.js is a JavaScript runtime engine, right, that can execute JavaScript on the console, right? And it has all sorts of libraries that make it very, very easy to implement HTTP servers, right? And that's I'm going to be using the Express library, right, to implement these HTTP servers, right? They can receive HTTP requests, right, and then send back a response. The communication between the two, right? We are using the HTTP protocol, right? Again, there's tons of protocols that we could have chosen from, right? We specifically are using HTTP. It's by far the most popular protocol, right, to establish communication between two endpoints. Okay, and so now there are there are many different ways that we could encode the data that we're going to send between the client and the server, right, between the browser and the Node.js Express. There's different ways that we could structure that communication. We're going to be using a very popular way of organizing or structuring that communication, which is called a RESTful HTTP requests, right? A RESTful communication, right? That imposes certain best practices, right? Certain naming conventions, right, on how to structure that communication between the two. Okay. All right. Okay, so first of all, we have to make sure that we have Node.js installed, which obviously we must have because we've been working with Express, right? We used it we installed Node.js at way back when so that we can create our React application, right? So certainly you should have done that already. Now what we're going to do is that we're going to create a Node.js application from scratch, okay, which we're going to be making it into our server application, right? Node.js applications don't necessarily need to be servers. You can build pretty much anything using Node.js, including web applications, right? That's what we've been doing with React. React is a mechanism. It's an infrastructure for building user interfaces using HTML, right? But it's all running inside of Node.js. So we've been doing this already, right? Now here we're going to build an application from scratch, right? We had used Vite, right, as our build tool to create for us a boilerplate React application, right? For the Node server, right, we're going to do it from scratch, right? We're not going to use any building tool or whatnot to create for us a a boilerplate server. Instead, we're going to do this from scratch. Okay, so let's see. Let's bring up a terminal, right? And what we're going to do is let's go to NU. Let's go to our directory where we are doing all our work. Uh, so yeah, so we're going to create a folder, using the same name that we've been following, this naming convention. We're building a Canvas because that's the application we've been building throughout the semester, the Canvas application. So, and we've been focusing on building the front end part of this, right? The user interface. And now we're going to be focusing on building the server side, right? So let's create a directory based on the same naming convention. We'll say CD. And so I'm going to call it Canvas Node Server App plus, for this particular section, right? And also I'll probably add for this particular semester. There we go. And so, oops, no, I did. I meant to create the directory. There we go. And make sure it's there. And so now let's go in there. Canvas node server app CS. And as you'll notice, right, it's completely empty. There's nothing there. And so here's where we're going to build our Node application, our Node HTTP server application. We're going to first initialize it as a Node.js project, right? And the way we do that is we use npm, right, to initialize it. We say npm init, and it's going to suggest a name for the application based on the folder name. I'm just gonna accept all the defaults, right? And what's going to do is it's going to create a package JSON file, right? And this package JSON file describes our project, right? It describes dependencies, where you can see the content here. And it has the author. I could put my name in there, whether there's a Git repository for this, if there's a license, any description. But in particular, the more important part of this is that you can describe the dependencies, right, that your project might use, right? And that's very common in any project, in any language, in any infrastructure, right? Usually, the programming language that you choose, in our case, JavaScript, there's nothing peculiar about the language. Usually what it's interesting is a community that builds around that language, all the libraries and open source and projects, right, that become very popular among developers, right? In our case, we're going to be using the Express library, so we can install the Express library. And what it's going to do is that it's going to make an entry into the package JSON file. So we can look at the package JSON file again, and you'll notice that now there's a dependencies entry that says that this project, right, we installed Express, and I'm going to record, right, that this project depends on that particular library. It also makes a new entry here. Creates a directory node_modules, right? So this folder, right, contains all the compiled libraries, right, of whatever we install. In this case, we installed Express. It'll include, source code for implementing that library plus any other dependencies that library depends on, right? So it downloads and installs and compiles, for my particular operating system, right? That are used for this particular project. Okay. So now I can write code that I should be able to run right from the console. So for instance, let's just create a small little file, and we'll call it hello.js. Right, and in here we can type console log hello world. That right. So it's a very trivial Node.js JavaScript application, and I'm gonna quit. And now we have a new file, hello.js, and we can now run it right from the command line. We can say node, hello.js, and there it is, hello world, right? So that's the most trivial JavaScript application. And so we're going to be building on this, right? We're going to build an entire HTTP server from scratch, okay? Right, so we installed Express, so let's create the simplest of HTTP servers. Let's open up our favorite IDE, right, and open up that folder and start coding in there, right? So let's go to code, and we'll open up a new window, right, so that we can open that folder, Januzzi, NEU, Spring, Node. Okay, so I think it's this one. There we go. Say open. Okay, so here we have hello. So our entry point for our new application is going to be more or less the way we did it on our front end. The entry point over there was index.tsx, right? I think, right? Yeah, the entry point for our application, it's this right here. Oh, main.tsx, right? On our server, we're going to make our entry point index.js JavaScript. Right? So this is going to be our entry point. And so in here, we're going to do a few things. We're going to bring in the Express library, right? Actually, I have a here, so let's copy it right there. Let's copy that. So let's look at this code for a second. So what it's doing here is requiring the Express library that we installed, right? And giving me a reference to that library, an instance to that library. This is the equivalent of our import statements, right? This is using an older JavaScript style, right, of coding, right, of dependency in between files, right? It's called CommonJS. But we're going to modify this in a bit, right, so that it uses the same syntax that we've been using so far, right? We've been using the modules syntax, right, that uses the import statement, right? So we'll do that in a minute. But as for now, right, this is the equivalent of importing the Express library, and now we have a reference to it. Internally, we can create an instance of the Express library. Once we have an instance of the Express library, we can program, right, our code, right, so that it can listen to incoming HTTP requests. You can say, hey, application, listen for incoming requests at this particular port, right? HTTP communication occurs across multiple ports for different, right, for different operations, right? A computer will have an IP address, that is unique across, every computer has its own unique value, own unique IP address, but within that IP address, right, you can open up, or you can listen at multiple ports, right? And there are many different ports that are dedicated to different for different tasks, right? So there's one for FTP, another one for email, right? Another one for HTTP, right? Typically for HTTP communication, servers by default listen at port 80, right? And for SSH, right, for FTP, each one has its own port dedicated for that specific communication, right? And port 80 is the standard port for HTTP requests, right? Now, we're not going to be listening at port 80. We could, right? That's where browsers assume that that's where the requests that the server is going to be listening at, that's the default port. So whenever you navigate anywhere on the internet, right, if you're not providing a port number, when you type in the URL and whatnot, and you don't provide a port number, the default is to use 80, right? The server is automatically listening at port 80. Now we're not going to trample over that port, right? Because it might be already in use, right? So we're not going to trample on it. Instead, we're going to choose a different port here, which port 4000 is a very common port number for Node.js developers. Right? There's thousands of ports, right? That one is the one we're going to be using. Now, when it's listening, we can configure what to listen for, right? So here, for instance, it's listening for an incoming HTTP GET request, right? So the HTTP protocol, network protocol, communication protocol, has what are called many types of verbs, right? For different types of operations, right? If you're sending me data, or you are requesting data, or you're modifying data, or deleting data, there are different verbs or methods that the HTTP server recognizes, right? The most common is GET, HTTP GET, and that's what you typically do when you navigate to any website, and you type the URL and you do enter. The browser is generating an HTTP GET, right, to go fetch data, right? So if if you go to Wikipedia, right, if I open up the tab here, and I look at the network, we can see that all these requests, right, are for the most part GET requests, right? So if I type here, wikipedia.org, okay, you'll notice that all these requests that go out, right, these are all request methods is GET, right? So here's the HTTP request, right? This is the name of the website, which typically this maps to a particular IP address, right, of the server that is listening at port 80. Notice that it's not I'm not specifying the port, right? And so that means that the browser by default, right, is sending this request to port 80. We can override that and say, oh, I don't want port 80, I want some other port, right? And we can use it by providing the colon. You can say, colon something, right, that I want some other port 5000. But we don't have anybody listening up port 5000. Actually, let me see if it's port 80. No, that one, no. I don't know what mechanisms they use to
It's
route.
Professor,
Yes.
it's HTTPS, so it's 443, right?
I'm sorry.
Uh, it's a HTTPS protocol, so it is port number 443, right?
No, I believe it's 80.
It is a HTTPS protocol, not HTTP.
Oh, S, right. Yes. For S
Yeah.
protocol, it would be correct. Yes. Oh,
Okay.
was it S? Is this S?
Yes, yes.
Oh, it is S. Yes, correct. Thank you. Then yes, it would be, what is it for? What is it?
443.
Yeah, excellent. Yeah,
443.
right. If it would be HTTP without the S, then it would be port 80. But I think it redirects you to HTTPS for security. Yeah, it redirects to S. Yeah, thank you. So what we're doing here, right, in our code is that we're saying, hey, I'm waiting for an incoming HTTP GET request, right, and I'm pattern matching the incoming URL, and if the URL matches this pattern, right, then right, I'm going to call this function. This is the work that I'm going to do, right? And it's a function where you can encode here whatever you want. In the function, you can encode, going out to the file system, or going out to some network, some remote uh, resource, right? Or connecting to a database, getting some data, whatever. I don't know. Here we're doing something trivial. We are responding, right? We are immediately responding to the request, right? Typically, you would do some work, do some work here, right? And compute something very complex or whatever, right? Once you have the result of that computation, after querying some database or some file system, some operating system work, right? The result, then you can send back the response, right, back to the client, back to whoever requested this, okay? And so basically this function allows you to participate in the request response cycle, right? The server, the client sends the request. We'll learn how to do that. The client sends the request. Here we are receiving the request, right? And that request is represented by this object here. So any information that the sender, the client, wants to send me, right, will be available in this request object. It could send me data. It could send me entire JSON objects, right? Plus a whole bunch of meta information, the IP address where the request came from, right? Some cookie information, some header information, some meta information, right? Plus some JSON data might be in there. And then, right, I would extract that from the request, right? That would allow me to compute some parameters encoded in the query string or in the path, the entire path. I can parse out the whole path, right? So I do some work, and then I can send back in the response, send back some whatever result of that computation, right? Here we're just sending hello world, and that's it, okay? So let's run this, right? So we can run it. We can say now we have index.js there. So we say node index.js like that, okay? And so now we can try it out and by navigating there. So it's listening at port 4000. So we can say localhost, our local machine, listen at 4000 with hello, right? And that's the hello world text, right, that the server is responding with. Make sense? Pretty good? Okay. Now well, let me see if I'm forgetting something. Okay, so right, to run this, right, we're using node index.js, right? So if I make some changes to my code, right, say, hello world, and I make some changes, whatever, save, yeah. If I come back to my browser, right, and I make the request again, you'll notice that those changes don't take effect immediately. I don't see the new text that I modify in my code, right? It's because my server is still running, right? To see the changes, I need to stop the server with Control C and then run it again. And then when I come back here and I refresh, then I would see my changes, right? But that's very cumbersome, right? It's not very convenient. So instead, what we're going to do is that we're going to use a tool, right? A library called NodeMon that can restart my server whenever it checks to see that any files have been modified lately, right? And so that you can see the changes right away without having to stop the server, start the server, stop the server. Yeah, so to use NodeMon, you need to install it locally. So here it's a global install, meaning once you install it globally, you don't need to install it ever again, right? It'll just be available at the command line. Now, if you are on Mac OS, you might need to use sudo, right? So that it gives you more authority, right, to install certain packages globally. And then you can just run nodemon. So we're going to do that. We're going to say nodemon index.js. So now it starts the server, right? And the changes are still the same, right? So those don't. So if I refresh, it's still good. But now if I make changes to my source code, I say 234. When I save it, you'll notice that it will restart the server. See that? It automatically restarts the server. So that's very convenient because now if I refresh, I can see my changes right away, right? So yeah, please, right, make use of NodeMon, right, so that it's convenient, right, for you to quickly develop, right? So for instance, here we're making a new change we're going to add an additional endpoint to my code here, save it, that I am creating a root default route, right? Saying that, hey, if you don't provide anything in the route, I'm going to assume that this is the root, right? There's and so my default response, right, will be you're welcome to full stack development, right? So if I go here, my changes to hello take effect, but I'm going to remove. So I'm at the root now, and I refresh, it comes back with welcome to full stack development without me having to stop and restart the server. Okay. All right. So ES6, right? We want to be able to use the more modern syntax, right? Especially since we're going to break up our application into multiple files, right? We don't want to use the older syntax to be able to import, right? So instead, we're going to change the type of the application, right? So that it uses the module instead of the common JS style, right? So if we go to package JSON, right, we can change the type. So type, you'll notice that there's two types, right? There's common JS, which is the default, right? We don't need to do anything. But if we want to override it and be something else, the more modern syntax, we're going to do module, save that. You'll notice that the nodemon saw the change, it restarted the server, and it crashed, right? And the reason it crashed is that the index.js now is using a syntax that it doesn't understand. I don't know what this require is. That's for the old syntax. Please use the new syntax. So instead of using this older syntax, we're going to import express from express. And I save that. The server restarts correctly, and now it's up and running. And my server works the same way as before. Okay. Another change that we're going to do is that we're going to add a start script, right, to our package JSON. And this is important for the when you're going to deploy this remotely on Heroku or on render.js or wherever you decide to host this server, right? They need to know how to start your server, right? And typically what they're going to do is that they're going to do npm start, right? And so we need to translate that into the actual command that starts your server. Now, we're going to be using Node still to start the server, right? So locally, we're going to be using nodemon for development purposes, right? But once we're done and we deploy this to this remote server, or that remote server needs to know how to start the server, right? But that's not for development, right? It's already running. It's production. It's the final product, right? So it's going to use Node, right? We're not going to be modifying files, right? Remotely. And if we do, right, what will happen is that everything will be redeployed. The server will be brought down, right? Will shut down, and then it will be restarted brand new. So no, not nodemon for the remote server. When you host remotely, only locally we're going to be using nodemon. For remote hosting, we're still going to be using Node. Okay. Okay. All right. So routes. So all these app.get, right, that we are defining here, right? These are all called routes. Okay, these are somewhat equivalent, right, to what we did in the front end, right? When we were using React.js routes, right, and then we would define a route and a path, right, and an element, blah blah blah. Yep. And what it did is that it was a mapping, right? The routes in the React application was a mapping of URLs, right? In particular, everything after the hash, right? A mapping between the URL and what front end component or screen you would see. Yes. So here is somewhat equivalent. It's also a route. It's saying that for this URL, okay, this is the function that I'm going to run, and the result of that execution is whatever finally the response comes back, right? So in that sense, it's the same, it's equivalent, right? But in the front end in React, the mapping was between a URL path, right, and some visual representation, whereas here the routes are a mapping between a URL, a path, right, and some response from the server, right? Now that response could be HTML, right? We could respond here, right? You using HTML like that. So if I come back here and I go to hello and I refresh, now this is this is being interpreted as HTML. Before it was being interpreted as simple text, right? But now the browser, even though it's receiving only this, right? The refresh. Notice that the response that's coming back is literally these characters, right? H1, hello world, close H1. That's all it's receiving. The browser is interpreting and says, oh, it's HTML, right? So it interprets it, it recreates, right, an entire HTML DOM, right, to, with a head and the body and everything, and then it injects the H1 in there, right? Also because the dot send here, the dot send is smart enough to understand what is being responded here, right? When it was just plain text, okay? So for instance, so here where we're receiving text, right? Welcome to full stack development. If I look at the network and I see the response and I click on it, right? Notice that there's the text coming back, right? The header, it's responding as, this is texts, right? And there's no formatting, and the browser is not doing any extra work, right, to represent this as in any other way. Whereas in this here, because it knows that it sees that it's formatted as HTML, right? It recreates, entire DOM, right, to represent it as H1. But notice that, I'm only just responding just plain text, right? I'm not responding HTML and head and body or anything like that, right? The browser's doing all that extra work. Uh, so also send is very smart. Depending on the type of content that you are sending back, right? It will create the correct headers and the correct types, right? So to give the clue to the client or the browser, right? How to consume the data, right? Should it be on your JSON object? Should it be a PDF document? Should it be a PowerPoint slide document, a CSV file? What is it? Okay. Is it a movie? Is it audio? Dot send is very powerful, right, at understanding the data type of that's being responded and creating the necessary headers, right, so that the browser can consume that data correctly. Right. Now here we're going to be building a lot of coding here, right? We need to build obviously all the labs that we're going to be working on today, right? Also all the work for, all the data that we have currently in the browser, like, courses and modules, assignments, quizzes, all that, right? Enrollments, users, right? So currently all that data is on the browser. So all that data is going to come back here. We're gonna move this over to a server, and eventually we're gonna move it to a database, right? That's really where it belongs, in the database. But we don't have the database just yet. So the data is gonna move here, and we need to, give access to the data, and and also all the operations of being able to create a new course, delete a course, update a course, right? Same thing with modules. So here we're gonna have a lot of endpoints, right, for each one of those operations. So this file is gonna grow, out of proportion very, very quick. So we're going to be able to break this out into separate files, right? And where each file is responsible for a subset, right, of the work, right? So for instance, let's move these out of here, right, into our hello. So let's move it into hello. Now, the problem with this hello is that we don't have this app, okay? And so what we're going to do is that we want to be able to, from here, import hello, where we have moved all these routes over here, right? So what we're going to do is that we're going to wrap this whole thing into a function, right? And this is going to be, and we're going to export this function, and we're going to call it hello. So there it is, right? And this function, we're going to be using it so that we can receive a reference to this app, the instance of the Express library, right? We're going to pass it as an argument. So we're going to import, right, this hello function, right, and then call it, passing it an instance of the app. And so here we're going to import the hello from the hello.js, right, .js. Now, typically, right, we would not need to add the .js extension, right? And definitely we don't in the React side, right? Since it's implied, right, that it's a JavaScript file or TSX file or whatever. Here, the way we achieve that on the React side is that there are several other libraries that that do some magic, right? That can resolve these files or directories correctly. Here we don't have that, right? So we need to explicitly say what the file name is that we're importing, right? Otherwise, we would have to do some more configuration of some tools, which I'm not going to do. So I imported hello, and now I can, call hello and pass it a reference to the app. And by doing that, if I go back, hopefully my server has restarted, and I should be able to be back in business. If I say refresh, that still works. Just to confirm that this is true, I can make just make some change here just to confirm. 1, 2, 3. If I refresh, there we go. My changes are taking effect. Okay. Yeah. So we moved it over. So hello here, right, is kind of like a route, a router, right, that is has several routes. So hello is a router, right, and in here we're implementing several routes. Okay. Now the style, the way we implement the route, it could be implemented either by embedding the function in the route like this, or if you prefer, right, this could be a separate function. You can say const hello equal like that, and then provide here a reference to hello like that, right? And same thing for this here. We can cut this out, and we can use maybe the older syntax. We can say function home. Yeah, that's good. Welcome to the home page, or actually welcome to home page. That's fine. And then home, have it here like that. Home. There we go. Either we could use the new syntax, right, or the old syntax. Either way, right? If we're not using the keyword this, it doesn't really matter which one we use, right? One is perhaps more verbose than the other, right? And then you can just put references here. Either way, it works the same way, right? Hello. Oh, hello. Oh, yeah. So hello, 1, 2, 3. There we go. So it works. Okay. All right. All right. So let's talk about the lab exercises. We're gonna go through several examples, right, of that is going to allow us to practice several fundamental skills, right, that we need to know about, right, to implement a Node.js server, HTTP server, right? And so again, this is the architecture of what we're building, right? We're going to focus on the server now. Our client for now is just going to be our browser, right? At some point later today, we're going to, connect the client application that we've been, that we have so far, right? We're going to integrate that into our server. But for now, our client is just going to be our just a browser, right? We're going to be typing at the URL, right? And right, and hitting all these RESTful APIs, right, to try it out and test it. Once we're happy with that, we're going to come back and integrate it with with a React client. Okay, so here's our very first lab exercise. We're going to create a lab 5 function, which is going to host all our exercises, right? Now, these slides are color coded, right? Because the some of the code entails working on the server side, right? Some of the source code goes on the server side, some of the source code goes on the client side, right? On the React side, right? So if it's blue, right? Notice that here it's color coded, right? Yellow is the client and blue is the server, right? So if you see here, lab 5 index.js blue, then that means this is code that goes on the server side, right? And also typically I'll use, this color code, to keep you, up to date on, which side are we working on, right? Sometimes it's hard to understand, oh, well, where are we? Obviously here, because it's app.get, that kind of is a giveaway that we are on the server side, right? But nevertheless, I hope the color coding helps out a little bit, right? So on lab 5 index, right, we are going to create here at the root lab 5 index, and we're just gonna code in this simple route. So it's a router which is gonna have several routes. Okay, and so the root, right, it's gonna be slash lab 5. So all these routes, all these paths are gonna start with slash lab 5, and then several additional paths, right, depending on what operation that we want to work on. Okay, so here's a welcome, welcome message for the lab 5, right? We're going to import this lab 5, right, in our index. So import lab 5, and we're going to pass it an instance of app. And now we should be able to go to the browser and type, localhost 4000 slash lab 5 slash welcome, and it'll say welcome to lab 5. So let's see if that is the case. So that is lab 5 welcome. There it is. So welcome to lab 5. Perfect. Okay. And now if we are integrating this with the front end, right, with our current React application, we can do some really simple integration, right? Not much more different than typing the URL here at the browser. The simplest way that we can integrate our React application is just have a link, a hyperlink, right? That if I click on that hyperlink, it just navigates here, right? And then the server does whatever it needs to do, and then responds with this message, right, or data or whatever. It's the result of computation. It's not much of an integration, but it's a start. Right? Later on, we'll do some more integration that will integrate it into our application. Okay, so we can create a lab file. Notice the color coding, right? So this is a lab file index.tsx. That's the entry point into our labs in the React application, right? So let's see, we have here, it is our Node application, and this is our React. So here's our labs. Let's create a new file, lab file index, and then we can create a hyperlink. Notice that this lab file is just a header and a hyperlink, right? That if I click on it, it should go to the same URL that I was just demonstrating, right? And I'll call it welcome, and it should navigate here, right? It should navigate there, right? Okay, so let's try it out. So once we have that lab 5, we can include it on our table of contents, right? Let's see if we can add lab 5 here. 5. So there's lab 5, right? We'll need a route for this. Let's see, app, labs. We'll need a route for lab 5. So lab 5 and the new lab 5 screen. Let's import it here. Import lab 5. And let's start the server Um, okay, so to start that server, and we should be able to navigate there. Let's see. There we go. Ooh, too big. Let's go to the labs, lab 5, and there's our hyperlink, right? So this hyperlink, presumably we'll just navigate here. Right? So let's click on it. There we go. It navigates there, and the server responds as expected, right? Welcome to lab 5. Okay. Okay. And so a lot of the first set of exercises are like that, right? They ask you to create some URLs, right? That you click on it, right? And then it goes out to the server, passing some data, passing, some path information, right? Doing some work on the server, and then the server responding, right? So very, very simple. Later on, we're going to introduce how to implement RESTful APIs, right, using Axios, and how to do real integration between the React web front end, right, and the Node.js server, right? Okay. All right, so let's talk about environment variables, right? So one of the challenges when you are developing applications is that there are oftentimes several environments that you're working on. For instance, the environment that we're working on right now, we could call it the development environment, right? This is where we are developing our application. It's also a good name for it is my local environment. So my local environment typically constitutes my development environment. This is where I do my development. And then the final where this is going to be running on, right? Typically that we refer to as the production environment, right? The final product that I am sharing with the world. And then in between there might be several stages, right? Where it's not development, it's not production, but it's some intermediate environment, right? That is making its way towards production, right? That is you know, iteratively being tested, right, and validated, making sure that it works, right, trying to catch all the mistakes, right, before we are able to deploy it in production, right. These other intermediate environments might be, QA for testing, might be um, stress testing, right, or load testing, right, that are testing in different ways, right, trying to push the application to the limits, right, trying to identify weak points that we can fix before it makes it out to production, right. So we need to be able to handle multiple types of environments, right? And in each environment, will have its own database, will have its own file system, right? It will have its own networks, its own infrastructure, right? My local environment, then the QA environment, the production environment. These are all incrementally more um, powerful environments that reflect the reality of where this is actually running. My local machine might be small line, teeny tiny little machine that certainly I can run tests from me, but the production environment, typically it's a much more robust server, set of maybe multiple servers running, working together, in round robin, right? That has some router in front of it, with with a lot of resources, right? That maybe my small little machine doesn't have, right? So I need to be able to work. My source code needs to be able to run on multiple of these environments, right? So I need to have configuration that allows me to interact with the outside world, so that my source code, right, is agnostic, right, of who am I actually talking to in the environment that I'm in, right? So any dependencies on the environment should not be in the source code, right? It should be somehow outside of the source code so that I can modify those dependencies without me having to modify the source code, right? So for instance, one of the things that we currently have in the source code is that this hyperlink assumes that my server is running on localhost 4000. And that's true on my local machine, that's true. But when this deploys on Netlify or wherever, right, this is not going to be true anymore, right? The actual server is going to be running on Heroku or on Render.js or wherever, right, or Amazon. So it's a bad idea to hard code here, right, the actual IP address or port number, right, of where that server actually is, right? So these dependencies will be different depending on where I'm running, on what environment I'm in, okay? So this a better solution to this would be to have a variable here or constant that can be resolved at the environment level, right? Have a variable here that I can import with the correct value depending on the environment. Okay, so the way we do that is, at least on the React side, the way we do that. Oh, and we need to be able to have these environments configurable for both for the React application, right, and for the Node.js server application. They both have the same issue. Okay, and so locally, I want to be able to configure and say, hey, locally here on my machine, my server is here at HTTP localhost 4000. But when this deploys on render.com, the server will be in a different place, right? It'll have a different name. It'll have a different port number. Right? But locally, this is true for me. And what we do that is that we configure that in a file that has a specific name, right? Uh, either on the file or, as we'll see a little later in Netlify, you configure it, using the UI for Netlify. Netlify has a UI that allows you to configure all these this environment variables, right? So I'm going to create this locally on my React.js application. .env.develop. There we go. And in there, I'm going to create a variable name. There we go. Right. So this variable name has a very specific name, right? In particular, notice that it starts with Vite. See that? So this is what glues this file to the Vite infrastructure. Right? Remember, we built this React application using the Vite tool, right? And so it has certain magic happening, right? That knows about Vite, okay? And in particular, it knows that these variables that start with Vite underscore inside our env file, right, are going to be available from the source code. I'm going to be able to import these variables, right, from the source code, so that so that the source code becomes immune to the actual values, right? I don't want to be dependent on the actual value, because when this gets deployed on Netlify, this variable will have a different value. It will have the IP address or the server name, right, of your server, right, running on Heroku or Amazon, right, or wherever. Okay. So now that I have that, from within my labs, right, in my lab 5, I no longer need to hard code this, right? Instead, I can import, right, that variable like this. I can say import. So I can just import here like that, right? And then here, instead of having hard coded this, I can just this could be an expression now. It could be an expression, and this could be like that. And then this URL can be computed on the fly, right? I can now replace this with a variable like that, $sign. See that? And if I go back here and I go back to my lab 5, refresh, if I hover, you'll notice that down at the bottom, it still says localhost 4000. See that? So if I right? If I refresh and I click on it, it still works. Right? It goes to localhost 4000 using my environment variable. And here we have an exercise, right, that demonstrates that you can create a component, right, and read the value. Right? So yeah, so let's do that real quick. So if I can do, there's a little exercise just that demonstrates that we can read that value, environment variables. So we can grab the code here, right, and then in lab 5 we can import that new component, the environment variables. There we go. Save that. If I go back to my Vite, if I refresh, notice that indeed, see that remote server is displaying the content of my environment variable. Okay. Okay, excellent. Which is just remote server, which I've imported. Make sense? All right. Now on the server side, I also need to be able to do the same thing, right? Right. I need to be able to configure my environment on the server in the same way. Right. So, for instance, in the one of the things that we don't have is the port number when we are running remotely, right, on Amazon or render.com or right on Heroku. And so that port number is determined at runtime, right? When the server starts up, right, it'll look up an environment variable called port, right? And so to do that, no, this is supposed to be process. There we go. So what we're going to do is that in our index file, on the server side, right here, instead of being hard coded to 4000, this is fine locally on my local development environment, right? But when this runs on Heroku or whatnot, right, the port can't be hard coded, right? That's determined at runtime, by the server provider, right? Your Amazon or whatnot, right? And it provides it inside of a variable called process.env.port, right? That locally I don't have it declared, right? Which will be null. I don't have it, right? And so we put an or, right? So if it is null, then it'll default to 4000, which is fine. Locally, we do want it to default to 4000, but when it runs in Heroku, this value will exist, right? It will exist, and it will use that port instead, right? Instead of 4000. And so this code works both locally on my machine or wherever environment this is going to be deployed on. Okay. And so this still should work. So refresh. Yeah, the server still works. Perfect. Okay. All right. So let's talk about how can we send data to the server. Right? There are three main ways that we can send data to a server. Two of them are very easy. The third one is a little bit more involved, right? So yeah, so this is the architecture that we're working on, right? We have the client, we have the server, and so for the let's take a look at one of the ways that we can send data to the server, right? So let's create a path parser, path parameters, right? That is going to demonstrate how we can pass data to the server, right? So inside of lab 5, let's implement path parameters, and let's code this. And let's take a look at this code for a second. Okay, so this is a route, a router, right, that declares two routes. They both start with lab 5, right? They both accept HTTP GET requests, right? They both start with lab 5, but then one of them says add and the other one says subtract. And you'll notice that they both have these funny looking colon A, colon B, right? And this is very, very similar to what we did on the client side when we were declaring routes, right? And we wanted to have, one screen navigate to another screen and then encode data from one screen to the other, right? When we, for instance, navigated from our dashboard, right, from the canvas, right, from the dashboard rendered several components, several courses, and then when you click on the course, the URL was encoded this way, right? Slash canvas slash courses slash the ID of the course, and then whatever, right? And so this caused the navigation to another screen, and the URL had, in the path encoded the ID of the course, and then using :cid allowed us to retrieve the ID, using use params, right? And then we use CID for looking up the course from the database, blah blah blah, whatever. So so we want to be able to do something equivalent on the server side. We want from the client, to be able to send a path to the server and encode data in the path, just like we did on the user interface. But here on the server, right? Uh, we would encode it, but obviously we don't have a user interface, right? We don't have hooks. We're not running on React. Okay, here we are running on the using the Express library. Okay, in React, the hooks, these use params hooks were part of the React router library, right? That parsed the path, right? Looked up for the CID location, right? And then gave you the value. On the server side, we don't have the React router because there is no React, right? It's not a front end, okay? But still, we want to be able to have the same functionality of parsing the path, right? Extracting data from the path. So we have a different syntax, a different way of doing it. Remember that I mentioned that, right? That when this path is intercepted by the server, it invokes your function, right? And it passes to that function uh, the two objects, right? One is the request object and the other one is the response object. Now, the request object represents everything that is coming from the client, from the browser, right? From the React application, right? And so including the path, the path that I actually typed, right, to navigate here, right? So the path is available here, and including, right, the whole path, but also, right, it will have, if it pattern matches, it will have parsed these locations A and B and created an object for us, right, available in the request, and that's in the request param. So request params on the server is the equivalent of use params on the React side, right? And here we can extract A and B, right, by the name that we gave it in the path, right? And then we can do whatever we want with it. We know that we're expecting these to be numbers, right? So we're going to parse them into integers. Otherwise, they would be considered to be just plain text, right? So if I don't parse this, then this would be considered a concatenation, string concatenation, as opposed to arithmetic addition, right? So here we're doing an addition, and we are returning the string representation of that integer addition. And this subtraction. This is very important that I convert it into a string. If I left it as an integer, right, and I send back an integer, the browser will interpret that as a code, as a status code, right? Because servers oftentimes respond with a status code to the browser saying, oh, everything's good, or something's bad, 400, or I can't find it, 404, I can't find what you're looking for, right? So these integers, are interpreted by the browser as status code. So here I'm converting to a string just to make sure that the browser doesn't interpret this as a status code, right? So anyway, so I can import this into my lab 5 lab 5. How am I importing it? Oh, there it is. So I'll go to just import here, import path parameters, right? And then we'll do path parameters app. Okay. And so I should be able to now go to lab 5. I can say add, 1, 2, 3, and 2, 3, 4. I guess that didn't work. Is my server not running? Oh, crash. Waiting for the file to change. Ooh. What is it that it did not like? Users, blah, 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 lab 5, cannot find modules, canvas, blah, 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 path parameters. Oh, you know what? It probably is because I did not provide a .js. There we go. Now started correctly, and let's try it again. Is it not lab 5? There we go. Yeah, so add 1, 2, 3 plus 2, 3, 4, or I can subtract. What is it? Subtract? What is it? Path parameters. Oh, subtract. So let's do subtract. There we go. Minus 1, 1, 1, 1. Perfect. Any questions? Now from the front end, right? It's asking you to create a component called path parameters that allows you to practice how to integrate with the server, right? It creates a little 2 fields where you can type in the values and click on the buttons, right, to cause invoke the URL. Right? So here's the input fields where you can type numbers, right? And then it encodes in the URL, right? Add or subtract the values of A and B that you type into the input field. So work on that, get it to work and make sure that you understand how that works, right? So another very important way how we can send data, remember there's 3 ways that we can send data. One is with path parameters and the other one is with query parameters, right? So query parameters encode the data at the end of the URL, right? Whereas path parameters, right, encode it as part of the path, right? As part of the path. Query parameters encoded at the end, after a question mark, right? And encoding it using name value pairs, right? A equal 3, ampersand, B equal 4, ampersand, and so on, right? So let's take a look at that. So let's create query parameters here. And so here, let's encode it here, implement there. So let's and so it's going to work more or less the same, right? The only difference here is that instead of query params, it's instead of being request.params is request.query. Okay. And again, it parses the question mark at the end of the URL. We'll see that in a minute, right? And extracts the values of A and B plus any other symbols there, name value pairs, right? And then you can use them internally however you want. What I've done here is depending on the operation, it's implementing a little calculator and where you can give me the operation as part of the parameters, right? And then depending on whether it's add or subtract, I run the addition or subtraction, and I ask you to implement, more things such as multiply and divide and whatnot, right? So let's add this to the lab 5. So let's import the query parameters and pass the app. And so now, I should be able to implement, right, and try the calculator. So calculator, I think, right? Is that what I called it? Lab 5 calculator, right? And then question mark, right? All the other things. So for instance, I could do operation add, right? So there's I'm expecting a named parameter called operation with a value. So operation add. And so I'm going to compare the operation against whether it's add, subtract, whatnot. So this is add. So it's going to run this part right here. And then I can provide the other parameters, ampersand, A equal 1, 2, 3, ampersand b equal 234, right? And it says that it can't find it. Oh, because I misspelled it. Calculator. There we go, right? So either add or subtract. Subtract, yeah, subtract. And then it comes back as subtract. Okay. Yeah, so those are the two main ways that you can send data from the server, right? From the client back to the server, right? Using either path parameters or query parameters. And and here, it's asking you to create a little component on the user interface just to practice, how to integrate with the, how to encode the data. There it is. So calculator question mark encodes the, the operation and then the values as part of the URL, right, at the end of the query string. So, practice that. And so that those are the two main ways, right? And so now, the more important way that we want to be able to send data back and forth is by sending, whole objects. We want to be able to send you an entire object, and then you'd be able to respond with an entire object, right? And I want to be able to manipulate individual pieces of an object. So that's going to be working on next. Okay. So let's take a quick break, and when we come back, right, we'll work with objects and more complex data types such as arrays and so on. Okay, all right. I'll be right back, and don't go anywhere. All right. Okay, let's continue. All right, so we've discussed being able to retrieve some simple data types from the server, pass in some simple data types as parameters encoded in the URL, either as path parameters or query. Let's take a look at how we would start dealing with objects, right, or maybe even arrays. Okay, so for instance, the server can represent objects, just like the client on React.js, you can also represent objects, right, and we can manipulate them. Now the difference here is that if we modify an object in the client in React, right, using, for instance, useState, right, to modify an object or a variable and whatnot, those changes are lost when you refresh the browser, right? Now here, right, if the URL on the browser, right, is refreshed and you reload, right, the all those changes are lost, right? Whereas on the server, the lifespan of the data is wider, a little broader, right? It's the state of the changes is maintained as long as the server is running. Right? Obviously, if you restart the server, any of those changes are lost, right? But at least, right, we want to be able to see if we can expand the life cycle of the data, right? At least from the point of view of the client. From the client's point of view, if I want to make changes, instead of making them locally on my React useState or reducer, if I make the changes on the server, right? As long as the server is running, it doesn't matter if I refresh the screen in React, right? I can always go back to the server to fetch the state. Okay, so let's practice this a little bit, right? Let's create an object, right? Inside a file, working with objects, so we can practice that. So in here, let's create working with objects. And so let's paste that in there. That's it. So I'm declaring just a regular constant on the server, and I'm creating an endpoint, a route that allows me to retrieve that assignment. Okay, right, let's bring that into our server. So this is working with objects. There we go. So that should be now available. I should be able to hit this lab 5 assignments and it will respond with this, right? Now notice that because we know that we are sending back JSON, right? We should use this more narrow, more targeted version of a response, right? This function specifically allows you to send back a JSON object, right? Making sure that the headers, right, are going to include the correct type that is being sent back from the server, right? So we're using JSON. I mean, you could also use send just because send is so smart. It can tell that you're sending JSON and it will correctly send the correct. But .json is specifically optimized, right, for that purpose, right? It does verbose, it's faster, right? It does some additional validations, right? So now if I go back here, I should be able to go to assignment. I can say assignment, right? And indeed, it comes back with the JSON object, right? That is the server is making available at that particular endpoint. Now, my browser is formatting it like this, pretty and whatnot. In reality, it's coming back as raw data. It's just one long piece of text, right? But I installed this little uh, plugin in the browser, right, that parses it and it makes it look pretty like this and expand and collapse and whatnot. Okay, and you're welcome to do something similar. So anyway, so that allows us to go fetch an individual object. We could also retrieve individual properties of the object. For instance, we could say, well, maybe I don't want to retrieve the entire object. Maybe I want to retrieve just the title, right? So for instance, a good endpoint might be that you say slash assignment slash title, right? And so that we return just the title, right? So that here now, if I just say, oh, I just want the title, right? Notice that just returns the Node.js assignment, right? Which is only one of the properties of the object. Make sense? Right? Uh, and now the lab exercises have additional work that they ask you to implement about be able to integrate the React lab exercises with the servers lab exercises, right? So I'm skipping over that, but certainly you should work on that. Now, how about modifying data, right? We can also modify data, right? Where we can send in a new title, for instance, right, as part of parameter, as part encoded in the URL. We can retrieve that new title and then just update the local object, right? And then send back the new version of the assignment. So for instance, we can add another route here, right? That if I send a new title at the end of the title property, I can parse that. You notice the name here, right? That those match. And then I can use that to modify the current object. So this one now, if I go back, this is Node.js assignment. I can grab the assignment. I can say, give me the title. So that is the current title, but I can convert it into React router navigation or something, right? That's the assignment, right? And then so it updates the object and then it sends me the whole object, which includes the new title in there, right? So I have effectively made the change, right? Now, if I go back and I retrieve the title and I refresh, notice that indeed comes back with the new title and the slash assignment. If I refresh, notice that it comes back with the updated value of the title, the new object, right? And that, if I refresh it, it survives the refreshes as long as the server is running, right? This will stay modified, right? If the server restarts, then obviously we lose those changes. To make it truly permanent, we would have to save these changes to a file system, save, retrieve, whatnot, right? Or even better, right, store these permanently in a database, right? And so that's going to be the topic of next week. Okay. Yeah. So we we were able to modify the title, and there's also a React component that plays around with modifying that title. Okay. All right, so let's talk about more interesting data types. So we've been working with individual objects. More interesting things is that is being able to work with arrays, right? Being able to append items to an array, delete an array, or update something in an array, things like that, right? So let's create a new component. Call it working with arrays. So new in Lab 5 actually. There we go. And so this declares an array. Notice I'm declaring it as a let because I'm going to be modifying this array. I'm going to be appending or removing or modifying individual objects, right? And so here's a router, right, that declares a single route that retrieves the to-dos, right? So let's include that in the lab 5. So this is working with arrays. There we go. And so we should be able to retrieve the to-dos here. So if I go to-dos, right, it returns the array of all the to-dos, right, which is the object, which is the array that is declared right here. Okay. So now let's try it out, different operations. Right. So for instance, one of the things that we'd like to be able to do, right, is filter the to-dos. Maybe I want to filter by one of the properties, right? Now to-dos have different properties. It has the whether it's completed, it has a title, it has an ID. So I should be able to filter or find, right, or delete based on any of these three properties. Right? So for instance, let's filter out using a property in a way that it can return more than one, right? So for instance, there are, for instance, two that are completed and two that are not, right? So if I filter by completed, false or true, it'll come back with, true, two have been completed, two have been not completed yet, right? If I filter by title, typically titles presumably might be unique, right? So it will return just one object, or I might filter or find, look up a particular object by its primary key, right? And that too also should return just one item, right? So let's play around with some of these operations, right? So for instance, we would like to be able to retrieve the to-dos. Now, we already have, right, in the to-dos that returns all the to-dos. Since we want to be able to filter, typically, we need to pass in values by which we want to filter, right? So for instance, if we want to filter by completed, we want to be able to pass in, completed true or completed false, right? We want to either retrieve those that are completed or those that are not completed. Those are two ways that we can filter by the completed flag, right? Now, we're going to use as a convention that that if you are filtering by a field that is not a primary key, then the filter value should be encoded or provided to the server, encoded in the query. Okay. But if you are filtering by a primary key, so if you're filtering by title or by completed or any other field that is not a primary key, right, then those fields should be encoded in the query. But if you're filtering by the primary key, right, the value that you're filtering by, right, should be encoded as a path parameter. And this is entirely arbitrary, right? It's a convention, right, that I'm now enforcing and saying, if you're going to be looking up for, in a collection of objects, if you're going to be filtering by non-primary keys, encode that data in the query. If you're filtering by primary key, then do use the parameters, right? Path parameters. So let's take an example. Since we are filtering by query, right? It would be at the end of this, query question mark, completed true or completed false or something would be part of the parameters I'm passing in. And so it would look something like this, right? So right before this response JSON, right here, right, we're going to extract the query, the completed query, right? Completed equal true, completed equal false, and from the query after the question mark. Now, it might be that I'm not filtering and I'm not providing any completed flag, right? If it's the case that I don't provide any filtering whatsoever, then, I would default, by responding with all the objects, right? All the entire arrays, right? With the objects in the array. But if I do have a flag of completed true, completed false, if it's not undefined, then I'm going to compare it. So is it equal to the true string, the completed equal true, or not, right? If it's true, then I'm going to convert it into Boolean, and then I'm going to do the filter. I'm going to take the original to-dos, and I'm only going to keep the to-dos, right, whose completed flag is true or false, right? And then I'm going to respond with that subset of to-dos, and I'm just going to return right away. Boom, right? Now, obviously, if I didn't have any completed flag, then I would just come back, right? I'd do my default work and just respond with all the to-do. So let's see how that works, right? So I go back here and I say, query, right? Completed equal true. There it is. So it comes back with tasks 2 and tasks 4. They're the only two that have the completed true. And if I say false here, right, comes back with task 1 and 3, which are the only one that's have completed false, right? So it works, right? And again, I decided that, right, the way that I wanted to encode this was in part of the query, and I'll tell you why in a minute, right? Now, if instead I want to retrieve by primary key, where is it? If instead I want to retrieve by the primary key, okay, I would do something like this: app.get, right? It would be lab5. As I said earlier, right, it would be encoded, right? So the AI is already reading my mind. Okay, it would be encoded as part of the path. It'd be slash to-dos, and then the ID would be encoded at the end. Okay, and then I would extract that ID, right, from the parameters, and I would try to find that to-dos, from the ID. I would convert it into an integer, right, and compare for the ID that I'm looking for. If I find a to-do, then I just respond with that one to-do. Otherwise, if I don't find it, I'll send back a 404 status and then send back some error message saying to-do not found, right? So now I should be able to, if I retrieve all the to-dos, there they are, 1 through 4, right? And then I can retrieve a particular to-do if I just provide the ID that I want. So I say 2, there we go. So it comes back with that one particular item, right, whose ID matches the parameter. Okay, so that convention that I just came up with, that if I filter by primary key, that I would encode the primary key in the ID in the path, right? Whereas if I am filtering by the if I'm filtering by something other than the primary key, the encoded would be part of the query. That convention is part of a set of conventions that are referred to as RESTful APIs, right? So an API is an interface, right? It's an application programming interface, right? That allows you to integrate two pieces of software, right, that establish a contract saying, hey, these are my endpoints. You're going to encode the data this way. I'm expecting things to be named in a particular way, right? And and you have to send me this formatted in a particular way, right? And this is what I'm going to respond to you, right? And so this API, if they adhere to these conventions, like this particular convention of encoding the data this way, right, is a part of a set of convention called the RESTful web APIs. Okay, and so let's take a look at some of those other additional conventions, right? So first let's see the way we would implement things without REST, right? And then we'll convert it into RESTful. Okay, so for instance, yeah, okay, so this is the working with monkey, retrieving arrays. So this retrieves all the arrays. This one, okay, there it is, right? Retrieving data by primary key. We just saw that. Um, Filtering by completed. We saw that already. So how about creating a new item in the array, right? So let's implement it. Let me show you. So first, let's implement it using a mechanism that does not implement RESTful, right? So I'll implement it right here. There it is, right? So the way I'm creating it is that I get /todos create, and so if you say /todos create, it will create a new instance of the to-do here with a new ID using get time, and then it's going to push it to the end of the array and then respond with all the to-dos, right? So let's see if that works. So if I say, get all the to-dos, there they are, right? All the to-dos is just 4. But if I say create, it'll create this random to-do, and there it is. That's the new one. If I run it again, it'll create another one. There it is, right? So there's a whole bunch of them. Okay. Yeah. So this creates new to-do. Now notice that I declare this right before this one over here, right? The order matters. Right? If I instead put this in the other direction, like that, where this was declared first, this won't work, right? Because these routes are consumed in the order in which they are declared, right? So for instance, if I say create here, it's going to assume that this create is an ID. So if I run this, right, it's going to say, I can't find a to-do whose ID is create, right? So that's why this is running first. The create, it's considering it as an ID, right? This runs, it doesn't find it, and then it doesn't continue. So to make sure that doesn't happen, right? If you have these paths are basically colliding with one another, right? There's an ambiguity between these two paths, and the way the ambiguity is resolved is that first one wins. Okay. And so that's not what you might want to do. You might want to say, well, I know there's a ambiguity, and I want to resolve it so that first this is we pattern match against /create. If that doesn't match, then treat it as an ID, right? So that if I now do a create, notice that it adds works the way I expected, right? Whereas if I do 3 or 4 something right here, it returns that one to do, right, as expected. Okay, so careful, the order matters. Okay? Now we're going to revisit this in a minute, and then instead of using /create, right, we're going to use app.post, right? Because that's part of the convention, right? The convention says that if you're going to retrieve data, then use .get. But if you're going to create new data, then don't use .get, use .post, right? Which we're not. We're breaking that convention. Okay, and the reason is that from this path from the browser, I can only generate GET requests, right? From with this little URL bar here, the only thing I can generate is GET requests. To generate posts, I would need to use JavaScript, right? Which I don't have just now, right? But later exercises walk you through using JavaScript. Okay, so here we're going against the convention, right? So we can't say my web API is RESTful because I'm not using the convention, but in a minute we are. Okay? So how about delete? Right. So here's delete implemented, also not following convention. Also not following convention. Because also one of the conventions is also in RESTful APIs is that the URL should not include verbs. And delete is a verb. Create is a verb, right? The URL should only include nouns, right, or primary keys. Right? So this definitely is breaking the convention. So delete is extracting the ID from the path, right, and then looking for the index, and then is splicing that particular item out of the to-do. It works, right? It's just that it's not following RESTful APIs, right? So if I go back here, and here are all the to-dos, right? These are all the to-dos, and we can delete, right? To-do number 2, say 2, that's 2, and I can delete it. So delete, right? And notice that it's no longer there, right? We have 1, 3, and 4. Okay. The to-dos just contains 1, 3, and 4. If I refresh, it just comes back, right, as the modified array as expected. Okay. Yeah, so none of those follows the convention, right? This one shows how to modify a title. So let's implement that. Let's implement that. So for instance, to modify a title, if you give me the ID of the to-dos, right, and the property that you want to modify and the new title, I'll go on and modify that to-do, right? Modify that particular title of that particular to-do, right? Okay. All right. Okay, so how do we do this? How do we actually implement RESTful APIs? We want to use post to create, HTTP delete to remove. We want to use HTTP put, right, to modify an existing object, right, and get exclusively for retrieving data, not creating any data, right? So for that, right, we're going to need to send these requests, post, put, delete, get, right, programmatically from the user interface, right? JavaScript is going to need to send these types of methods, right, so that to control the server, right, to do certain operations, right? So back in the architecture, we want to, instead of us manually typing this, right, here at the URL bar, right, we want to programmatically do this, right? We want to be able to send these requests from the user interface, right, from JavaScript, right, and command the server to do certain behaviors, right, of adding, deleting, creating content, modifying, and whatnot, right? So for that, right, we're going to install a library that is going to be able to talk to the Express library, right, by sending HTTP requests, get, post, put, delete, that the server is going to be expecting, right? So let's install Axios on the on our React application. So here's our React application. It's running. I'm going to stop it for a second. I'm going to install Axios, and I'm going to restart. Okay. Oops. Resolve. What did it say? npm install Axios. Run npm run dev. Okay. Okay, so it's still, so the application, right, is still there in React. Huh? What's going on? npm install Redux. npm install Redux. Somehow it's complaining that I don't have Redux installed. npm install React Redux. And let's run again. Okay, that's weird. Yeah, so what we're gonna do is that once we have Axios, what we want to be able to do is make all those requests that we currently can do manually, right? That we can say you know, lat 5 welcome or something, right? We want to be able to do that, right? But from the user interface. I mean, we can sort of do that, right? Right? If we go to labs and we did lab 5, we did create a hyperlink, right? That we clicked on it and it went to, you know, welcome to lab 5. But when the way it's done is kind of lame, right? Notice that we are currently running on the user interface, the React application, and we are navigating away from it, right? And we are navigating to the server, leaving our React application. Yes, right? And then, you know, basically just typing localhost 4000 lab 5 welcome. Instead, we want to stay within our React application, you know, send the request out to the server, right? This same request, this identical request, but without leaving our React application, you know, receive a response from the server, and then update our user interface, right? Without ever leaving our React application. We want to be able to, you know, stay within, right? So how do we do that? We're going to be using our Axios library, right? So here's a trivial example, right? We're going to create on the lab 5 HTTP client, TSX. So here, under lab 5, lab 5, we're going to take a look at creating an HTTP client, right? So you know, this screen now is going to try and talk to the server. How do we do that? So the way we do that is, let's see, first let's copy everything. Let's take a look at the code real quick. So yeah, this we don't need. We don't need that. Okay, there we go. What we're going to do is that we are going to have a button here. Have a button that when I click on the button, fetch welcome, is going to call this function here, and is going to make an axios.get. So this is going to programmatically, right, go out to the server. So this is the equivalent of me actually typing this URL in the URL bar up there, right? But instead, I am doing it programmatically, right? Just generating a GET request out, and then I get the response from the server, and the actual data is embedded in the response.data, right? And what I'm going to do is I'm just going to set this state variable so that it can render down here, you know, response from server, welcome on click. So when I click, it generates the request to go out to the server, it comes back, right? Now, the request is asynchronous, right? And what we mean by that is that the JavaScript that runs on the browser that is going to make the request out to the server only has one thread, okay? And so this request, it cannot be synchronous. And by synchronous, what we mean is that it would establish a network connection to the server, and it would wait, right, until that connection is established, you know, and the response comes back, and so my single thread in JavaScript would be blocked, you know, waiting on the server to respond. And now that's very dangerous because the server could be down or it could take a while, before the server responds, right? Also, typically, it's the single thread in the JavaScript. I don't want to block it, because I might need to be doing other things, right? Like handling user typing and whatnot, right? And so I don't want to block the single thread. So instead, right, we want to rely on an asynchronous communication so that we don't block, right, this single thread. But the problem is that we only have one thread on JavaScript. So what we do here is that we are relying on the browser. The browser has multiple threads, right? And so we are delegating to the browser, hey, browser, go off and do this request. I mean, you do this all the time, right? You download audio and video, right? And CSS and JavaScript and HTML, right? Simultaneously, you connect to all these servers and you download all these resources simultaneously, right? Well, here's one more, right? Go fetch for this for me, and I'm not going to wait for you. I'm just going to go off and continue, handling user input, right? And so to do that, to establish that asynchronous communication, we are introducing two new keywords: the async and await keywords. Okay, so this is telling the infrastructure that this function is going to be asynchronous, right? It's not going to block, right? It's not going to wait for the server to come back, right? The request is going to go out, but it's not going to wait, right? Instead, right, it's going to delegate this to the browser, and the browser is going to notify me, when the request comes back, when the response comes back, right? And then it'll continue, right? Now there is some magic happening behind here. This gets actually compiled into into a different syntax, which makes it clear that there's a callback from the browser, right, with the response. But that syntax is it's somewhat archaic and really hard to follow. So that's why they introduced these two keywords, right, which almost looks like it's synchronous, the syntax, right? It almost looks like, hey, I am waiting for the response to come back, right? It looks like I am blocked here waiting for the response to come back, and then I'm going to continue to the next line, right? In reality, right, this gets compiled into a different syntax where this only actually happens, right, inside of a callback function when the response comes back, right? Then this function is called, okay? But here, this syntax, right, the await and async syntax allow you to write it without that archaic syntax. Okay. Anyway, it is asynchronous. All right, so let me demonstrate so we can add this to the lab 5 here. So this will be HTTP client. So HTTP client. There we go. And so we should be able to, let's see, no. Okay, there's our HTTP client. And so we can see, we can inspect, right? We're going to be using the network tab quite a bit now for development purposes, because what we want to take a look at the communication between our client application and the server, right? So anyway, so when I click on this, notice that there's a request that's going to go out, right, out to the server. So fetch, okay, there it is. So welcome. Notice that the header went out, the request went out. There it is. So lab 5, welcome. And we did our get request, right? Now notice that there's an error saying that we are violating a security policy, okay? We are violating the course security policy. Course stands for cross-origin resource sharing, and that error is entirely expected, okay? Yeah, this is what the expected course error looks like, right? We're trying to access, what's happening here is that my React application is running on localhost port 5173. But the server is running on a different port, localhost 4000. And so the browser interprets this as a security breach, right? That one JavaScript running in a different server is trying to communicate with some other resource, right, that is not accepting its requests. Right? So it flags it and say, no, I asked the server is not accepting requests from you, right? So by default, right, I'm going to block the request. Okay. So how do we fix that? So the way to fix that is on the server, we can turn it on. We can say, hey, we are actually going to allow anybody to talk to us for now. We're going to narrate a little bit later, but for now, we're going to open up for everybody. Anybody who wants to talk to me, I'm good. Talk to me, right? So we're going to install a library called course, right? So we are under Node.js here. So we're going to do npm install the course library, right? So that's installed. And then on the server, we can in our entry point, we can say, we can turn on, we can import course. So import course from course. And then we can say app.use course, right? So what this is going to do, okay, is that app.use, very much like our app.get, right? It's a, app.get basically compares, looks like, make sure that the request is get and that the URL matches this, whereas app.use intercepts all requests, regardless of whether they're get, post, put, delete, doesn't matter. It doesn't matter what the path is, right? It looks at all the requests, right? And it looks at it, notice that the order here matters, right? Remember that these routes, right, they are interpreted, right, in the order in which they're declared, right? So notice that this is interpreted before we get to hello, before we get to lab 5. So what it's doing here is that it's going to the course here, right? We're creating a new instance of the course library, and we're not providing any configuration. We'll add configuration in a minute, right? But the default configuration is that it's going to allow anybody to talk to it, right? It's going to open it up. Hey, I'm accepting requests from anybody, right? So now let's try it out again. So let's install it. Let's run nodemon index. So it's running now again. So let's try that again here. So let's do the fetch welcome. Okay, so notice that this time, right, we don't get an error, right? And there it is. So welcome. So the response that came back from the server is the same that was coming back when when I typed it, when I myself manually. I'm getting the same response, the same URL. This is the same exact URL as what I typed manually, and I'm getting the same response. There it is, right? And we are intercepting it in the code, right? We are intercepting it and then setting it. We're setting a state variable, which we then render over here. Make sense? Okay. So how about yeah, so course was able to open that up, right? How about the fact that we might want to not on click, right? Not on click, but wait a minute. Course configure course. So we did configure course, creating a client library. So these requests that we are going out to the server, currently we are implementing it right here, right, in the TSX file, right, in the rendering portion of our React application. And so from within our component or screen, right, we are sending a get request out to the server. Now this is typically considered to be a bad practice, right? A better practice is to separate these two roles, right? Very much like we separated the rendering of data and then manipulating that data, we move that over to a reducer, right? Same thing here, right? The rendering of this data should be in here in the TSX, but the fetching of this data or interacting with the server should be outside of the component, right? So let's do that. We're going to create a separate file. We're going to call it the client file. Oh, oops. What happened? Where'd it go? Okay. We're going to create a client file, and we're going to move this communication right over to that other file, right? So we're going to create here client, and basically we're going to recreate the communication in this file without any rendering whatsoever, right? So we get the remote server, there it is, the axios.get, it's an asynchronous function, and we're going to return the data, right? So now we can rewrite this by importing the client. You can import the client like that, right, right here. We're going to import the client and rewrite our fetch welcome on click, but using that new function in the client. Right, we can rewrite this right in terms of the client dot fetch welcome message, and then we get the message from the data. We can set the local state variable, right? So we no longer need the remote here. We no longer need Axios because all that right is inside of the client. Right? And now if we try it again, this should work just the same way. So refresh, clear, fetch welcome, and it works just the same way. Right? Now, so right now we are fetching the data from the server on demand, right? When we click on a button, right? Now it's very common that instead of me initiating the the action of to go fetch the data from the server, a more common way would be to just automatically do it when we first navigate to this screen, right? So on load, when the component is first loaded, for it to be initialized, so that it can initialize itself, right? It's going to automatically go out to the server immediately, right? Fetch the data, initialize itself, right? And then when it renders, it has already gone out to the server, right? So that's a very common thing to do. So let's create a new state variable, right? Where we can populate the data that we're going to get when we first load. We're going to create another function, right? Just like, it looks very much like the one we already have, but instead of, it's going to use exactly the same function to go fetch the data. Yes, but it's going to populate, a different state variable, right? The welcome unload. Now, how do we run this? How do we execute this? Now, to execute this, we need to use a dedicated hook for this, right? So there's a hook that I call the use effect hook, right? That it's equivalent to a constructor. It's almost like a constructor, right? Where the first thing that a constructor does, right, as it instantiates the class, right, is that it initializes its state variables and whatnot, right? And so use effect is somewhat for the same purpose, right? It's meant to initialize state variables, right? Most likely by fetching or interacting with remote resources such as servers and whatnot, fetching data, right? And once it's interacted with the remote, then it would update the local state variables, right? And then the user interface would be configured, right? So this typically works in tandem with useState. So very commonly you will see both of them imported from React, both useState and useEffect, right? And useEffect, yeah, again for that, right? For initializing with some remote service, right? So anyway, so we're going to call welcome onload, right? And so onload is going to call the server, right? It's going to populate this, and we're going to render it in the user interface. So we'll add a a little heading down below where we can display this right here. Okay. So anyway, so we go back here and if we go back, unload. Notice that if I refresh, this fetches it immediately, right? We see that immediately goes out to the welcome, right? Fetching the data without me having clicked on anything, right? And it populates that immediately. Whereas to populate the other one, right, I need to go and click on fetch welcome and does the welcome, right? Also notice that, yeah, so it's done at load time, okay? So let's take a look at re-implementing some of the operations that we were working on earlier, right? One of the things that I had mentioned is that some of the operations that we were implementing were not RESTful, okay? And in particular, when we were working with the arrays that to create a new array, a new item, or to delete an item, right, or to update an item, right, we were using things that were not RESTful, right? We were using verbs in the URL, right? We should have been using post, put, and delete instead of get, right? We were using get to create instead of just reading. Right? So let's revisit all that, right? Now that we have the endpoints, right? We're going to have to re-implement this so that they can use a post, put, and delete, right? And now we have a means to using Axios to programmatically create the post, to put, and deletes, right? So for instance, let's first fetch the to-dos, right? So in the clients, in Lab 5, let's create a URL for the to-dos, Lab 5 to-dos, and then an asynchronous function to fetch the to-dos, right? So let's do that. So in the client, let's there's to-dos API, and fetch to-dos is going to do a get for the to-dos API to fetch all the to-dos, right? And so in working with arrays asynchronously, let's create this component in the lab 5. What's going to do is that it's going to use my fetch to-dos to go retrieve the to-dos, and then it's going to populate a local array, and it's just going to render them, right? So let's paste that in there, and let's copy that too. And I think that's it. Okay, it's I think I missed something. Oh, I have an extra return here. There we go. All right, so let's look at it this real quick. So let's see. So we have a local state variable, right, where we're going to keep track of the array of to-dos, right? And instead of being declared locally, right, we're going to instead unload, right, when the component first loads. I'm going to call fetch to-dos, which is going to use the client fetch to-dos, which is going to do an Axios get, right? So remember, this here does an Axios get to the to-dos API, right? This one right here, lab 5 to-dos. Right? It's going to respond with the data, which is the array of to-dos. And then I'm going to set the local state variable with this array that I fetched from the server. Okay. When the state variable changes, it's going to cause a re-rendering of the component, and it's going to iterate over those to-dos, right, one at a time, right, and creating this line item with input fields, and then the text is going to, the title is going to be either strike through if it's completed or not. Okay. All right. So let's try it out. In lab 5, right, we're going to here in lab 5, being lab 5, let's bring in the working with arrays asynchronously. And let's see. There they are, right? There are my four tasks, right, that are being retrieved right there, the to-dos, right, on load, which the response comes back as an array, right, which is being copied into a local state variable, right, and then used for rendering, right? So no longer are we in the user interface going to be declaring any data, any hard-coded JSON objects, right, that are going to be loading or populating. So for instance, all the database that work that we've done on the user interface in the React, all that really should live on the server. And really, really, it should live in a database, right? So we're working our way towards the database, right? First, we're going to move it over to a server, learn how to work with JSON objects, because we do need to learn how to do that, right? But eventually, right, all that data that we're going to persist, right, that needs to go out to the server, to a database. Yeah. So now that we have the access to the to-dos from the server and we can render it, let's now you know take a look at how we can use the current implementations of delete, create, update, right, from the user interface, uh, and by clicking buttons, right, and causing things to happen on the server. And then we're going to revisit this, re-implement it using RESTful APIs so that we don't have any verbs or anything like that. But for now, let's use the endpoints that are there, right? So let's implement the remove to do, right? So in the HTTP client, it's this right here. So it's going to do a get, right, to do the ID of the to do, and then delete, right? Because that's the endpoint that we currently have, right, for the lab5 for the working with arrays, right? For the delete, it's lab5 to do's ID and delete, and that's what we're sending, right? So lab5 to do's, right? The ID of the to do, and then delete. So that will cause a delete on the server. Okay. And so back in the user interface, right? Let's create an event handler, right, in the component, so that when I click on a trash can, it's going to cause a remove to do. Is going to pass in an instances of to do. Right, it's going to use the ID of the to do to send it to the server, right? So here back in the working asynchronously, right? Let's add the remove to do, and let's add a trash can, right? A trash can right next to the title of the to do, right? So in here we have the input line item. Let's add the trash can right here. We'll need to import this. Let's see. There's our trash can, and if I click on the delete, right? Notice that the delete goes out. Right, here's the header, right? I'm deleting the first one, dash delete, and the response is that I only have the 3 left, right? And so the way this works is that when I click on it, right, I get the remove to do, and when I remove the to dos, it comes back with the updated to dos, which is missing the to do that I removed, right? So these are the to dos that survived, that comes back from the server, and then I just update my local state variable with the 3 to-dos instead of 4 to-dos, right? And the whole thing re-renders. Okay. Then let's see. So we have to do. How about creating a to-do? Again, using the current implementation, which is not RESTful. We'll fix that in a minute. So here's create. Same thing with /create. Right? It's going to come back with the new list of to-dos, including the new to-do. Right? And so let's create an event handler in the component, which is going to invoke the client. So right here, right? And then I guess we'll need the circle here. And then in the to-dos, we'll add a plus, right? So that we can click on that plus, right, to create a new to-do. So that will put that in the H4 right here. There we go. So we have the plus here. So that we create a new one. Create another one. There it is, a new task, new task, new task, new task. So we're creating a whole bunch of new tasks down below, right? If I refresh, notice that the to-dos still exist, right? Because the server is maintaining the array, right? The state is being maintained by the array. I'm just copying that state over into the client React application, right? And just copying it into my local state variable. So now the client state is always just going to be a copy of whatever this actual state is on the server, right? Even in the reducer, right? We're going to, re-implement it so that the reducer is never going to declare its own state, right? From local JSON files, it's always going to get its initial state from the server. It's going to go and request out to the server. It's going to copy the state over into the reducer, right? And then from there on, right, we update the user interface, right, as the state changes over time. Okay. So yeah, so we can create, we can delete, right? And so what we want to do, be able to do is, re-implement this in such a way that we don't need, we're going to implement them using RESTful, right? Instead of using those verbs, right? And that's we're going to be covering in the next lecture. Okay. All right. Yeah. So let's take a short break, and when we come back, right, we'll do office hours. Okay. All right. Let's see. Let's do some office hours. You ever hear me? All right. Let's see. All right. Who wants to go first?
Hi, Professor. I have questions about the 5.2.1 in textbook.
5.2.1. Okay, let's
Yes,
see.
it's adding the environment variables.
Oh, okay.
I try to copy the environment variables the code in my VS Code, and then I run the npm dev run, then I cannot open all of my contents. I don't know how to
Okay, do you
fix
want
it.
to, okay, you want to, I'll stop sharing. Why don't you share and show me
Yeah,
what,
sure. I
what the
can share
problem
my
is?
screen.
Go ahead.
Um, let me. Oh, where is the screen sharing button?
At the bottom of the screen, there should be a share
Oh,
at the bottom of the Zoom.
like here are the here my the right side is my code environment variables, and I also add the
Oh, yeah.
environment.
So see, wait, okay. Yeah, it's no longer process.env. And
It's not env.
oh, okay. Yeah, so I need to fix that. All right,
Yeah,
so today,
because in the textbook is env.
right, yeah, that, so we changed over to Vite, and so invite is different. Can you see my screen? Let me show my screen.
I can stop share.
Yeah, let me share my screen and let me show you. Can you see my screen?
Yeah.
Yeah, so that was when we were using npm create React app. Invite is different. The first of all, the file name is called .env.development,
Oh,
right?
so
And
the
so
name is
instead of React app, right, it's Vite underscore.
wise underscore. Okay.
Yeah, it's in the slides. I'm gonna fix the document tonight.
Okay.
And
I can.
then
Oh.
to use that, and then from React, the way to import it is that you do import.meta.env. So it used to be process.env. Okay. Now it's just
now it's import
import.meta.
meta.env.
Yeah.
Oh, okay. So it's like changing two parts. One is the env documents and the
Yeah, follow the slides. It's in the slides.
okay and the import one.
Yeah, I will fix the issue in the document tonight.
Oh, okay. Thank you so much, Professor.
right.
I will try this.
Yeah, sorry about that.
Oh,
We
nothing.
we just recently changed from create React app to Vite.
Okay, that's all my questions.
Okay.
Thanks.
Right. Anyone else?
Yeah, I'm having trouble with doing the reducers for assignment 4. I
Okay.
can share my screen
Go ahead.
with what I have. Right, so right now I'm trying to do the part, I couldn't figure out how to get it to go to a completely separate screen for the assignment editor, so I moved on just to do the delete assignment first. And
Okay.
this still isn't working, I think. Yeah.
Okay. All right, so can you show me
Like, no, I don't know.
can you show me how do you close the button? Okay, close button. Delete assignment pop-up. Assignment close buttons. Editor. All right, can you show me what's going on when when you display the assignments? Here it is, right? And then what happens?
So it goes to the assignment editor because I have that, like, these individually mapping to be links to the assignment editor.
Oh, okay. All right, so let's try and fix that first. Can I take control of your screen?
Yeah, sure. I don't know.
Wait a
Do I have
minute.
to allow that?
Wait a minute. Do that. Are you Tara?
Yeah.
Okay. Request remote control. All right, can you grant me? Okay. So, there we go. Okay. All right. So this one's the one who renders the items. This is it.
Yeah.
And then here's the close button, right?
Mm-hmm.
And the close button, delete assignment, blah, blah, blah. So is this even invoked? Delete assignment buttons. Delete button. So control button, blah, blah, blah. Current button, delete assignment, delete assignment. Wide assignment. Delete assignment. Hmm? Oh, this is another pop-up. This goes, okay, so you're
That is, yeah. Oh, maybe because I didn't put a string in there. I don't know.
I think you've over-engineered this a little bit.
Okay.
Okay, so we start here, right?
Mm-hmm.
And so let's try to simplify this a little bit. Let's just have a simple button. Let me see, we can even click on this. Let's see. Okay, there's a delete, right?
Mm-hmm.
And right now, if I click on this, it'll just navigate. Okay, yeah. So we want to intercept that, say, on click. And so this is the event. And we just want to see that if we can alert delete. Okay.
Okay. Mm-hmm.
Let's make sure that we can even just do that. Okay, there we go. But still navigates, right?
Mm-hmm.
So we don't want to navigate. So we're going to do E dot prevent default, right? So don't do what you normally do. Okay, now
Okay.
it's not navigating. Okay, good. So what is it you want to do? You want to delete, right?
Mm-hmm.
And you have a delete assignment in the reducer, which does what? Delete assignment, blah, blah, blah. So you're passing the ID of the assignment, and then you're creating a new array of assignments that is a filter of only assignments that are not the assignment ID. That makes sense. Okay. We have a dispatch, so we should be able to, it's not alert, we're going to dispatch, right? We want to dispatch your delete assignment, and we want to pass the assignment dot ID,
Okay.
right? That's what
Mhm.
it's supposed to do. Okay, so what happens if I click on delete? What happens? Console. Okay. Oops. Do I need to sign in?
Yeah.
As who?
I was just doing this one.
80123.
Yeah.
Which course? This one?
Yeah.
Okay. So here, let's make sure we have the assignment reducer. So that's the assignment reducer. Let's make sure we're even getting here. So delete. Do we make it here? We are. We do. Okay, good. So we make it here. So presumably this is working. I'm going to assume that it's working. Now, why don't we see it update? So delete DB. Oh, see, you're using the database still, right?
Okay.
So the assignments that you want are the ones from the reducer,
Mm-hmm.
right? So it would be const assignments from use selector of the state. So state dot assignment reducer. I think. Isn't that what you called it?
Yeah. Assignments. It's with an S, but yeah.
Assignments reducer in the store, right?
Mm-hmm.
And state. Any? Okay. Let's see if that works. Huh? What? Okay. Assignments. Huh? What is it calling this? What? Button on click and default. Dispatch. Are you calling this? Somebody's calling the delete. I don't know who is, maybe this here.
Okay.
Somebody's calling it. Okay. All right, so I need to filter it, but I'm not filtering right now. I'm just let's first let's see if this works. Delete.
And it's not getting there.
Okay, so it's getting there. Okay, there it is. So it's removing it. So it is removing.
Okay.
So yeah, so you need to massage this a little bit so that it's not all of them. Maybe here you could filter this filter here. You could put it here.
Mm-hmm.
I don't know, something like filter assignment a dot course equals CID or something, maybe. I don't know. Does that work? I don't know if that's going to work. Okay, yeah. Only for that
Okay.
course.
Yeah. And then why is it like still giving the error for assignment? Is that just the type being
Where? Where?
here? Is that probably just the type? Yeah.
Yeah, you could just say any or something,
Oh,
colon
yeah.
any.
Okay.
So yeah, massage this a little bit so that it works with your.
Right. Okay. And then for my like for when you go to edit an assignment, then or create an assignment, how do you get it to navigate to the editor screen and transfer over that information? Because I kind of the way I have it working is like it will go.
Well, aren't you going to the editor? I just
I
need.
am going to the editor.
I mean,
I think that's right here. Um,
so if I click on this, right, it goes to the
mhm.
editor. Isn't that working?
Yeah.
So what do
Uh,
you mean then?
to get it to be able to update the information or when
So
you're creating a new assignment.
when you're creating an assignment, all right. So when you say add assignment here,
Yeah, I couldn't get that. Well, because I could get that button to go to a assignment editor screen.
so what I think what you need to do is so as your editor, where's the plus here? Is that it? Is it with the plus?
No, it is on.
You sure? I think it's it.
Yeah, it's in the assignment controls right here.
Yeah,
Yeah.
plus, right? Here's the plus.
Mm-hmm.
Yeah, so this would be a link, I guess,
Mm-hmm.
or button as link, I think. Wait, I forget. What is it? As link? I forget.
Yeah, that works if you do like the navigate too, but
Wait, I'm just gonna make it a link. I forget what the syntax is. So this is just a link, right?
Mhm.
And so the link would be that um I guess me too. Oh, you have it, right? A link. Why is it complaining? Oh, two, maybe?
Yeah.
And so this would be
Canvas slash
so
the course.
canvas slash courses. Do you have the course ID?
Um,
So it'd be canvas courses CID, then assignments, and then because how do you oops how do you navigate here in the index?
I just go to 123. It's like a fake page.
Well,
That's
well no, I mean in
oh wait, no, here it's not. Okay. Yeah, I must have changed that.
so where's your link here? On
Right,
click.
here. Like up on 26 or 20.
Oh, there it is. Okay, so canvas. Okay, so it's canvas courses, blah 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 blah. All right, yeah. So in the control, is it where we were?
Mhm. Yeah, and then assignments and an assignment ID.
Yeah. So yeah. So this would be new.
Okay.
So in the editor, so in this AID, it's
Mm-hmm.
either going to be a real ID, right?
Yeah,
Or it's going to be the keyword new,
right.
right? So if it's if it's a real ID, then you would pick out, the actual ID, and also here you're using database again, right? So you can't use the database. You need to use the you need to use the reducer, right?
Okay.
These are all the assignments, right?
Mhm.
So if something like so maybe you can have like a state variable. Use state or something, right?
Mhm.
Where you can ask, right? If AID equals new, then this is a new state, right? It's a new assignment. Else, right? If it's not new, then this is a real AID. So you would find the assignment, the assignment, find where a, whatever equals AID,
Mhm.
and you would set assignment to A. Otherwise, if it's new, you can just initialize this with some bogus assignment,
Yeah.
like title new assignment. Description.
Mhm. My main like confusion is about when you go to that screen and then coming back and saving the changes.
See that? So it's new.
Uh-huh.
So it's new assignment description.
Yeah.
So this one, if you go, oh, I guess that didn't work.
Yeah, because we don't have the else. It's not in the else. It's like, right? Is that?
Wait, why didn't that work? Assignment. Huh. Too many. Oh, what an infinite loop. What? Where? Infinite loop, blah, blah, blah. What are you talking about? What is an infinite loop? I think maybe we need to use effect. Oops. Why is it not use? Oh, you already have it. Okay. So maybe the logic here. If AID blah blah blah, then we don't do anything. Otherwise, I am going to look up the assignments, and the one that matches the AID, I'm going to set the assignment. Okay, let's try that. Okay, there we go, right?
Yeah.
So that works, right? These are all existing assignments.
Mm-hmm.
But if I click on plus, I get a new assignment, right?
Mm-hmm.
And then
Yeah.
save is supposed to actually save, which I
Right.
don't know
That
what's.
was the main like part where it's like
So the
I'm not sure how to.
save, right? So in the save, you could do, const save. Did you work on this already?
Yeah, I had a lot of this working, and then I kind of thought I was.
So So in the save, you do the same thing, right? If AID is new, you're going to do a create.
Yeah, and
Then
I have that function.
where is it?
Well, in the reducer.
Yeah, and so you're going to call one or the other, right? So if it's new, right, then you're going to call the create in the reducer. Where's the reducer?
It's like add
So
assignment.
right, so you're going to call this guy, right? Passing whatever you need. So if it's new, but if it's not new, right, then you're going to call update, right, passing whatever it's expecting. So if it's add assignment, you don't need this because this is already, you're passing it already. The assignment already has this. You know,
Okay.
assignment,
For creating a
payload,
new
assign.
assignment, it would already have this.
Yeah,
thing.
because you're passing it, right? You already have it here, the assignment object.
Oh yeah, okay.
You have the assignment object, you would call new would be, I don't know, something like dispatch, add, what is it called? What do you call it?
Add assignment, yeah.
Add assignment.
Right, because we have the variable. Okay.
And I guess you need to import that Redux. And otherwise, right, then you can do the update. Oops. Right, so this would be adding and this would be updating.
Yeah,
And
okay.
so, and then in the reducer, you treat it one way or the other, right? So you already have this, so you don't need this.
Mm-hmm.
You have assignment. So you have,
Okay.
and update, maybe, yeah, this might look okay, I think. Anyway, something like that.
Okay.
Oh, you do, you know what you do need to do is make sure that the assignment gets the correct course. So when you save, you make sure that when you add the assignment, you pass in the assignment object.
Mm-hmm.
And well, I guess you could do that here. I guess you don't need to do that. You could
Do it in
here,
the
you
variable.
could here you say course has CID. Oh, you need the course ID. So this would be, you also need the CID here. And so to make sure that whatever new assignment you have is bound to the course that you're in, right?
Yeah.
And so,
And then can you just
what?
the save is gonna go into the button.
Yeah, the button you would call save here.
Okay.
Anyway, something like that.
All right. Let me see. So the save should just be like, oh well, this isn't gonna render anyway because I have all these like errors, but okay. Okay. Thank you.
Vedanshi, you have a quick question?
Yeah, Professor. Question. Is it okay with you if we can go into a private room or something like that?
I'm sorry?
Is it okay with you if we can go into a private room or something like that? That
Sure.
would,
Let me create a
yeah.
room. Vedanshu. Okay. I'll add you.
Okay.
Me as well.
Who?
Me, Siddharth.
Both of you in the same room?
Yeah.
Oh, okay. Vedanshu and Sidar.
No, like me and Viber,
I'm sorry.
me and Viber, in one room.
Okay, yeah, let me talk to Vidanshu and I'll be
Yeah,
right
okay.
back.
Yeah, sure.
Okay, Vidanshu, I just assigned you. I'll open the rooms. All right, I'm back. Let's see. There were two students that wanted to go into a break room.
So,
Yes,
yeah.
Cedar and who else?
Vibe.
Vibe.
Cedar and Vibov?
Yes.
Yeah.
Okay, wait a minute. Shokla, do you have a quick question?
Yes, Professor. I also have some doubts regarding the assignment, but it's okay if you just go ahead with Siddharth's question first and then add me in another room.
Okay, but Siddharth and Vaibhav, is this something personal that needs
It's about the project, and we were just brainstorming, and we wanted to ask about and just go about telling about our idea, and then we wanted to confirm and get started with it.
but right now, so do you want to go into a break room because it's private and you don't want folks to
Yes, Professor.
share?
Yeah.
Okay,
Yeah.
all right, okay. All right, so let me add you, so wait a minute, so Vaibhav, and Cedar. Okay, see you there. All right, I'm back. Let's see. Anybody had any quick questions? Anybody have any private conversation they to have? Okay, Shrugla, let's have a quick private conversation. Wait, okay, Sujal also needs a private. All right, let me talk to Shrugla first. Let's see.
Professor, you can add her in our chat room. We have some similar questions.
Oh wait, who?
Sujal.
Sujal and
Hello,
Shloka?
Professor. Yes,
Both of you in the same room?
yes,
That's okay?
yes.
Yeah.
Okay.
Mhm.
Sujal.